All right, so tonight we're going to talk about what's called displacement. And so what we're going to be looking at is inside of your engine, as we mentioned in the first couple of days of this little tour through the engine, you have the cylinders. Mr. Green, I have a 4-cylinder engine. Well, good for you. Mr. Green, I have a V6. Ooh, excellent. I have a V8. All right, good for you, whatever. Now, in math class, we always talk about this as a diameter. In auto shop, we refer to this as the bore of the engine. Okay? And this, which we normally call the height, out here we call it the stroke. So how do I find the volume of one of these guys? Well, volume of a cylinder is equal to pi r squared times h, and that's true. However, in the shop, what we normally write it as pi times the bore squared divided by 4 times the stroke. And the reason we do that is because we use the words bore and stroke. We use that terminology, not a radius. And since the bore, which is the diameter, is twice as big as the radius, when you square it, it'll be 4 times bigger, so you divide by 4. This is the formula that we're going to use in the shop. This is for one cylinder, volume of one cylinder. So what we'll end up doing, okay, is we're going to multiply it by, so to get displacement, displacement is simply the total volume of the engine. Of all cylinders. So how do I find that, Mr. Green? Glad you asked. It's going to be equal to pi bore squared divided by 4 divided by 4 times stroke times the number of cylinders. Okay. Now, we'll start off with doing some in American. So in American, we use inches, of course. So if you ran across an engine that was an 8-cylinder engine and had a bore of 4 inches and a stroke of 3 inches, what would the displacement be? It's a good question. So displacement would be equal to pi times 4 squared divided by 4 times 3 times 8. The answer is 301 point something. Mr. Coombe, how do you know that? Now listen, when I want you to use pi here, I want you to use the number 3.14. The reason I want you to do that is because that way, hopefully, the computer will be able to grade this appropriately. Okay, if we try to all use pi, it may or may not work. So I want you to use 3.14. 301.44. 301.44, or just 301 inches cubed, which is what Ford refers to as their 302 engine. Okay? 301 point something cubic inches. All right, let's do another one. Mr. Green, I have an engine that is a V8. It's an 8-cylinder engine. This one has a bore 4¼ inches and a stroke of 4 inches. So the displacement would be equal to 3.14 again times 4.25 squared divided by 4 times 4 times 8. .7 or 454 inches cubed. Chevy 454. Okay? We can play this game till we're blue in the face. I want to do a couple more. How about it? Let's play. So, Mr. Groom, what if you had an engine that had a 3-inch bore and a 3-inch stroke? That's a good question. I don't know. How many cylinders does it have? 4, Mr. Groom. It has 4 cylinders. We can do that. So displacement is simply equal to 3.14 times 3 squared divided by 4 times 3 times 4. 84 cubic inches. Yeah, yeah, probably. Yeah, yeah. It's not very much. No, no, it's not. Okay, it's tiny. Oh, let's do one like this one, Mr. Groom. Oh, come on, Mr. Groom, you can do it. 4-inch bore, 4-inch stroke. What? 8 cylinders. So it's going to be displacement. It's going to equal 3.14 times 4 squared divided by 4 times 4 times 8. And this one should come out to be 400 cubic inches, or right there. How do you know, Mr. Groom? 401.9, 401.9, or roughly 402 inches cubed. Nice. Okay. We play this game till we're blue in the face, friends. It's that easy. It is literally that easy. Literally. Okay. Now, just for fun, let me just mention this briefly. If the bore is equal to the stroke, like on this one, we call this square engine design. This is what they call it. I know the cylinders are round. They're not squares. I know. I'm just saying. If the bore and the stroke are the same number, we call it a square. That's just what it says, man. I just don't. I'm telling you right now. If the bore is smaller than the stroke, we call this under square. And if the bore is bigger than the stroke, it's over square. Okay. Ta-da! Bigger engines, like semis and tractors, have long, ginormous strokes. They don't move very fast. They don't turn very many RPMs. That's like if you watch Mr. Ford and I, if you've never met Mr. Ford in person, he's a short fella, 5'7" or something. I don't know. He's a small guy. When we walk somewhere, his legs are going 100 miles an hour because he has very short legs, a very short stroke, if you will. Mr. Groom has long legs, and so my legs do not move very fast. Even when I was younger and I could run faster than I do now, they never went very fast. And so that is I am an undersquare design, if you will, all right? I have a super long stroke, okay? If you got a 4-inch bore and a 3-inch stroke, we call that over square engine, okay? And so just be aware of that. It's something to be noted of. We don't reference it a ton, but once in a while that terminology comes up. It's literally just this relationship is all you got to worry about. All right, now, Mr. Groom, but today's engines, aren't they measured in liters? You are correct. Nowadays, we measure our engine in liters. Wait a minute. Liters isn't that like pop comes in liters? That's right. It's like 2-liter bottle. Sure. So it's how much it holds. That's right. That's right. So 1 liter is equal to 1,000 centimeters cubed. Okay. So when we're talking about metric style engines or metric designed engines, if you will, okay, we're going to look up a couple here in a second. What I want you to see is that they will literally be given in millimeters. Mr. Green would prefer, well, not prefer, I'm just going to show you what I do. 5.3 Chevy bore stroke. Cool, whatever. Now, so the 5.3 liter engine has a 3.78 inch bore. Oh, for the crying out loud. That is not, well, it's true, but it's not true. It is and it isn't. It's very annoying. Why is it in centimeters? Aha, why isn't it in centimeters? It's supposed to be in centimeters. Someone converted it to inches for me. I didn't want that. Ah, stop it. Stop it. Stop it. This engine was designed in metric. It's weird that they're showing it in... why are they showing it in American? That's weird. Aha, there we go. Cool, there we go. This one will have it. It's we got you, dog. All right, there we go. Cool. So the bore is 96 millimeters, and the stroke is 92 millimeters. So it's 96 and 92, I think, are the two that I want. I will give them to you on the homework. You don't have to worry about it. 96 millimeter stroke, or bore rather, I should say, and 92 millimeter stroke. Okay, and it's 8 cylinders. So the first thing I want you to do is rewrite that as 9.6 centimeters bore and 9.2 centimeter stroke. And then what do I do, Mr. Groom? Well, it's like this, friend. Displacement is equal to pi times the bore squared divided by 4 times the stroke times the number of cylinders. You're like, Mr. Groom, this is a big number. I got a huge number. Well, let's see what you got, friend. 3.14 times 9.6 square divided by 4 times 9.2 times 8. I got 5,324. Good night, nurse. That's a lot, Mr. Groom. Centimeters cubed. That's true. Oh, Mr. Groom, didn't you say that 1 liter was 1,000 cubic centimeters? That's right. Watch. 1, 2, 3. So that's a 5.3 liter engine. So in metric, you're going to want to do this. Pi times the bore squared. I'll write in centimeters. The bore in centimeters squared divided by 4 times the stroke, again in centimeters, times the number of cylinders, divided by 1,000. Okay, and that will give you the displacement in liters. Okay, let's pop up another one here just for a good time. 3.8 liter GM bore and stroke. That's right. Look at that. Betsy can read my handwriting. That's pretty sweet, yo. So check it out. The idea here is we are going to have a bore of 394.9 millimeters and 88.4. What did I say? 99.4? No, 94.9 millimeters and 88.4 for the stroke. This is a 6-cylinder engine. So first things first, friends. I'm going to rewrite that as 9.49 centimeter bore, 8.84 centimeter stroke. So displacement is equal to 3.14 times 9.49 squared divided by 4 times 8.84 times 6. 3,749 divided by 1,000. So divide by 1,000. Forgot that part. Sorry. It's 3.75 liters, which GM, for whatever reason, decided to round up. And they rounded it up, and they called it a 3.8 liter engine. But 3.75 is the correct number that I'm going for mathematically right now. Okay? I think we'll do one more, then we'll call it a night. And you can do this little assignment that's going to follow tomorrow. So let's do 22R bore. No, not 225, you jackwagon. R bore and stroke. Oh, shoot. Darn it. Rats. Bore and stroke. Little Toyota engine, that's a good time. All right. Yeah. Hot diggity, friend. Look at that. The bore is 92. The stroke is 89. Sarah. I don't know what just happened to that. Weirded me out. The bore is 92. Rewards a quality car. Judas Priest, 89 is the stroke. There should be a law against that. It kind of freaks a person out, you know? You're just sitting here all by yourself in a room, just making a little video for the kids, because that's what you do. You know, you're all about the children. Mr. Groom, it's for the children. Oh, well, then I'll do more work. Sure, why not? Yeah, and then some stupid computer screen starts talking, and it freaks the bejesus out of it. You got to stop and go clean out your underwear because you freaked yourself out. Holy mackerel! So displacement is 3.14 times 9.2 scorer over 4 times 8.9 times 4 divided by. Because again, we would like to have this in litras, not cubic centimeters. By the way, some of you have motorcycles. Mr. Groom, I have a 250. That's right, you have a 250. 250 what, Mr. Groom? 250 cc's. This is a 2.36 liter engine. Okay, that's what this engine was. Mr. Groom, I have a Honda CR250. Oh, I don't know if they make a Honda CR anymore. I'm just going to say, this is back in my day. Friend, no, let's go back in time. Mr. Groom's first motorcycle, Yamaha YZ100, 1977, the first year of the monoshock, kids. Wait, before that, they didn't have monoshocks? No, don't be ridiculous. Mr. Groom got the very first one that was ever produced. I got this when I was like 13. I thought it was pretty cool. My cousin had one. He had an RM 76, I think, Suzuki RM, and RM 100, and my friend had a 75 CR 125 Elsinore, and we had a good time. The three of us would bomb around and whatnot. Well, anyways, I got this thing. I thought I was pretty hot stuff, man. Well, I was. Let's be honest, right there it was. That's a good looking bicycle right there, dude. Still had the. It was like the last year, I think, for the metal tank before they went to plastic too. It's a good looking bike. Anyways, check it out. Suppose Mr. Groom wanted to know. I'd like to go back in time because I like to relive my past glory. Mr. Groom, does it have a bore and stroke? Yeah, it's got one cylinder. It's got literally one cylinder. Let's go check it out, friend. Let's check it out. See what's what. Oh, I feel like the bore was 50 and the stroke was also 50. Mr. Groom, that kind of means it's a square engine. That's right. So it's, by the way, check it out. What did it say? 50 millimeters? 50 millimeters. Bam, right there. You see where it says mm? Mm-hmm. So when I do this, it's going to be, the displacement is going to be 3.14 times 5 squared. Divided by 4 times 5 times 1, because there's literally one piston here. So if I do this with my calculator, what just happened? You moron. Mr. Groom, you divided instead of multiplying, you knucklehead. All right. 98 cc's, which they rounded up and called it 100 cubic centimeters. Now think about that for a minute. 100 cubic centimeters, which we would usually abbreviate that as cc's. If you wrote that in liters, you'd put, I got a 0.1 liter motorcycle. That sounds, well, anemic, frail, pathetic, sad, sorry, fruity. No, I got 100. All right, brah. Listen, Mr. Groom, my dad has got a Kawasaki Ninja 750 from the early 90s. It's pretty cool. It's a 750. That thing is just, it screams. Yeah, they were pretty cool bikes, and my cousin almost killed himself on one. But yeah, it's great. But 750 cc's, Mr. Groom, what does that mean? It means you've got 3/4 of a liter. That's it. That's pathetic. Yeah, 1,000 cc motorcycle would be 1 liter. Lame. time. So motorcycles have always stuck with the CC thing. Back in the olden days when Honda first started selling their cars in America, Honda Civic CVCC, yeah, 1976 model. How many CCs? I think they were a 1200 cc. Oh, 15. This was a 1500 cc engine. Right on. Woo doggy. And they would actually say that. They would write 1500 cc's on it instead of saying 1.5 liters, because 1.5 liters sounds, well, you know, sad. Okay. By the way, if you've never seen one of these, they're kind of cute. A buddy of mine had one back in the day. We called it the BTU. It was a basic transportation unit. A little itty bitty little car. Yeah, pretty sad looking little thing. But yeah, whatever. 1500 cc's, and that's what they just called them. Okay, they didn't say 1.5 liters. Anyway, so today we're gonna be doing a little assignment. Give me answer some questions on it. Whatever. Have some fun. Watch the video first. Otherwise, it's bad.